All right, these are your notes on Ohm's law. The lab that we were doing is related to Ohm's law. And Ohm's law is just a relationship between voltage, current, and resistance. So you write that up here, Ohm's law. And we spell it like this, Ohm's law. And this is the relationship between voltage, resistance, and current. The equation is simply V equals IR. And if you look at my window, you actually see this equation. Remember that if two numbers are two variables are right next to each other, that means that they're simply multiplied. Okay, so V equals IR. And let's talk about what these four things are. So V is for voltage, I is for current, R is for resistance. The only reason I know these is because I've been teaching for 10 years now, and I just remember them. So I actually, funny thing, that this is now the sign for battery. So I found this little sign for battery. Batteries are the voltage. These are the ones that are going to push the electrons. So your voltage is also known as the potential difference. Its symbol is V. Okay, so this V is for voltage. I'm just going to write it down here. Voltage equals. All right, and we said voltage is the potential difference in the circuit. It's measured in volts, and that's why there's a lightning bolt, right? So it's measured in volts, unit of volts. This is essentially what's pushing the electrons, okay? So I'm going to give myself side notes for all of these. And my big side note for this one is that voltage pushes the electrons. I'm trying to look for the hot pink one here, because I want you to write this so you remember it, write it in big letters, whatever you need, but voltage is what pushes the electrons. Okay. So let's move on to I. I is for current. And I'm sure that it's maybe a Latin word or something, but we're also running out of symbols. But I'm sure that current, maybe I, is used because it's some Latin word or something like that. But I is the current. And this one takes a little bit of time to memorize. That I is the current. I feel like every year I have a few students that forget that this is the equivalent of something that starts with the letter C, because everything else so far has started with the same letter as the first initial. Okay, even this, like this is resistance. Current is the electrons per second moving. The electrons per second, or the flow of the electrons. Essentially, this is how fast they move. So how fast the electrons move. And if you look here, the electrons actually move in one direction. They move from the negative side of the battery to the positive side of the battery. However, because whoever in the beginning started naming current, they talked about current moving in the negative direction, then this became the conventional current. But I will always talk about the electrons moving in the positive direction for you. But also want you to know that the unit for current is amps, because that one's also weird. So the unit is amps. And then the last little thing I'm going to do for you here, we're going to talk about the resistivity of a wire. So what gives resistance to a wire? So why did that light bulb light? That light bulb actually has some resistance. The resistance resists the flow of electrons. That's all they do. They prevent the electrons from flowing. So they prevent the flow of electrons. And sometimes they allow electrons too, like depending on the resistivity. So you have some types of metals are going to have a really low resistivity, like copper. So this is going to allow electrons to flow easily. This one's going to allow electrons not to move as easily as the copper. Okay, so depending on the resistivity to and what you want from it, then you're going to use different types of metals. So resistance is literally just resisting the flow of electrons or preventing the flow of electrons. Things that prevent flow of electrons are like your light bulbs. These are resistors. Appliances are resistors. And if you like by appliances, I cover everything. So, the washer, the dryer, the refrigerator, the hair dryer, all these things are actually preventing the flow of electrons. And we said this, I just want to rate that resistance resists the flow. Okay, so those are like your simple definitions, if you will. It resists the flow. The unit for resistance is the ohm. The unit is the ohm for Ohm's law, but nobody wants to write ohms. Like everybody's like, whatever, I'm not gonna write all this. So because ohm is so close to omega, they just write like a little backwards horseshoe omega symbol. It's a Greek letter. Okay, so this one is resistance. And I'm going to write the units right above each one of these, okay? So the unit is ohms. I'm just going to do that in a different color for all of them, so you have it. So these are the units up here for these guys. So V is volts. Okay, that's the units. I is amps, so you could just write A for amps. And then for resistance, you're going to see omega. And you're going to need these when you are solving for the problems. So when you see volts, that's voltage. When you see A, that's the current. When you see this halfway backwards horseshoe little thing, that is your resistance. Back to 4 things that cause resistivity. So the type of metal is going to affect resistance. So some metals allow electrons electrons to move more easily. And what do you want? You really just want whatever is needed for the electronic that's being created. Sometimes it might be better to have some cords because you need some resistance. There's parts in your computer that needs a little bit more resistance for like storage of memory. But then there's other parts that they need more electricity, so they're made out of copper wires. Okay, so in this case, these ones are less resistant, like copper, and then quartz is more resistant. And this is more resistant. And if you look at this piece of wire, these are your other three things. So the cross section, if it is a wider wire, the cross section, so wider diameter. And again, think about it, it's a flow of electrons. So think about it like a pipe. If you have a wider water pipe, then you're going to have more water flowing through it. So then this is actually going to allow for more electron flow. And the length of the wire is also going to affect the resistivity. Longer wires have